All right, if you're in an algebra course, you're dealing with y equals mx plus b quite a bit probably. This is slope-intercept form. The reason we call it the slope-intercept form is because m, the number that's in place of that m variable, is our slope. It's how we grow or how we decrease over time or whatever other variable we're discussing. B is our starting point, our initial value, our beginning, okay? So in this video, I'm not necessarily gonna go through any problems or anything like that, but what I'm gonna help you to do is understand why we need this equation and how to use it. So I'm just gonna go over a couple of examples, and by the end of the video, you should have a good, strong understanding of where y equals mx plus b comes into play. All right, so for something to have a constant rate of change, a slope, it's gonna be linear. It means it cannot change how it grows or how it decreases. For example, if we have a swimming pool and we gotta drain the pool, if we unplug or pop whatever we need to so that it starts pushing water out of the pool, it's going to decrease at a constant rate of change at the start, right? It's gonna be pushing out water the exact same amount every single minute or every single hour. You make the decision on what you're discussing. If you wanna go by minutes, great. X is representing minutes. If you wanna go by hours, X would be representing hours. It just depends on the scenario, okay? So because we'd be losing water, slope would be negative in that situation. You'd have a negative slope because you would be starting with however many gallons are in the pool at the beginning. So if the swimming pool is full and you know there's this many thousands of gallons in the pool, well, we're gonna be losing gallons. So negative, it's gonna be dropping from this point, and eventually this number is gonna get down to 0, right? So X would be representing your time, minutes, hours, whatever you choose there. Y in that case would be representing how much water is still left within the pool, okay? Let's go to a different example. Now we're not dealing with a pool, we're dealing with driving, okay? Let's say you're 5 miles down the road. You're already 5 miles away from your house, okay? And you are traveling at a constant speed. How would you travel at a specific constant speed in a vehicle? You'd set it to cruise control, okay? Now, human beings, we don't do things linearly very often, if ever. Okay, because we're humans and we can't be perfect with what we're doing. If I'm driving at 60 miles an hour, my toe is gonna push down and up a little bit. So I'm gonna fluctuate from 59, 60, 61 degrees. But if I hit it to cruise control and I say go 60 miles per hour, X is representing hours, 60 is my speed. Okay, remember I was already 5 miles down the road. Now what I can do here in this equation is I can just put a number in for X to figure out how far I've traveled total after a certain period of time. I've already gone 5 miles, so that's already done. But then let's say we've traveled for 4 hours, 60 times 4 is gonna be 240. Don't forget we already had traveled 5 hours before we started going 60. So in total, we've gone 245 miles over a span of 4 hours, okay? Now, the only reason I can do linear here is because a vehicle can go at a constant rate when you put it in cruise control. It's not gonna go to 59, it's not gonna go to 61. It'll be 60 miles an hour no matter what, okay? And one last example for you. Let's say I have a collection. Let's use a baseball card collection. I already own a big old collection of baseball cards. So let's say I have 25,000 baseball cards in my collection from when I was a kid. And then out of nowhere, I decide I want to start collecting cards again. So every month, okay, or every day, or every year, or every week, again, X could be whatever the variable is you decide, or what you're given in the equation provided to you. Okay, so let's just say X in this scenario is going to be weeks. Every week, I'm gonna go get a new pack of baseball cards. And in each pack I purchase, there's 5 cards. So that means I'm adding 5 cards every week because I'm buying a 5-card pack. Well, every week that goes by, I'm gonna add, so I put positive 5. 1 week goes by, 5 more cards. So just add 5 to your total. 2 weeks go by, you would be adding 10 total cards. So you'd add 10 to this. 3 weeks, 4 weeks, 5 weeks, it really doesn't matter. You can put whatever value you want in for X, and what it's gonna do is spit out your overall total of baseball cards after the certain number of weeks go by. Okay, this is what linear equations are all about. We can write them also in standard form and point slope form, but that's a whole nother ballgame. Right now, we're just talking about beginnings and changes from there. So we had the swimming pool, had a bunch of water in it, and then we dropped gallons over a period of time. We had a car that had already traveled a certain distance, and then it traveled more over a period of time. And then last but not least, we had a baseball card collection with a ton of baseball cards, and now we're gonna add 5 more cards every week. So we're increasing the overall collection by 5 every week. Y would be your overall total after a certain number of weeks. Okay, so let's just see. 22, let's do 20 weeks from now. So 20 weeks from now, how many cards am I gonna have? I just plug a 20 in there, and that's gonna help me to solve for Y. So I put my 25,000 that I already have. How many have I collected over a 20-week span? 5 times 20. Well, we all know that's going to give us 100. So I have 100 new baseball cards to add to my old collection. I now have a grand total of 25,100 cards. So what's Y representing? Cards. X was representing weeks. Hopefully this makes sense and you have a better understanding of how slope-intercept form works for you when you're trying to determine things down the line. Study hard and good luck on your upcoming test.